All right, we're going to start with graphing quadratics. And here are some important information. You might want to grab a pen and write down this axis of symmetry formula. It is on the algebra formula chart if you have access to your journal at home. Also, you can Google it. That's where I got this cute graphic, so I could post it on here. These are some important steps that you're going to want to follow when you're graphing quadratic equations. They help lead you to all the important parts. A refresh of what some of these words might mean are going to be on the next page, but the new vocabulary is vertex. We haven't worked with a vertex before, so you might not be familiar with it, but it's basically the highest or lowest point on the graph. So a parabola is the shape, and it's either the bottom of the parabola or the top of the parabola. All right, so a little vocab review. You already know what the zeros are. They're also called x-intercepts, roots, and solutions. It's written as an x value, comma, 0. You know a y-intercept. We've had that on every graph so far this year. Where you cross the y-axis, which x is 0, and then the y value. Domain is all possible x values. Range is all possible y values. Not new information. What is new is your axis of symmetry. It's a vertical line that crosses directly through the middle of the graph. It always goes through the vertex, and it's always written as x equals something because it's a vertex. All right, so we are going to graph the function f of x equals x squared. And if you recall, f of x just stands for y. So we're graphing y equals x squared. In order to graph a quadratic just means it's to the degree of 2, we are going to start by finding the axis of symmetry. If you recall on the beginning slide, it was the opposite of b over 2a. Okay, so what is our b value right here? We don't have one. So it's going to be opposite of 0 divided by 2 times 1. Well, we know 0 divided by anything is going to be 0. So our axis of symmetry is x equals 0. And I am going to do my best with my finger to draw a straight vertical line on our graph. So there's our axis of symmetry. Okay. Next, we are going to try to find our vertex. Well, the reason we start with the axis of symmetry is because it gives us the x value of our vertex. You okay? Sorry, she was choking. Okay, so if we know the x value of our vertex, then we can plug it into the equation to find our y value of our vertex. So if I plug 0 in as x up here, then 0 squared is what? 0. So our vertex is at the origin. Sorry, it doesn't like my mark. Okay, so there's my vertex. All right, now we're going to try to graph a few extra points so we can see the shape. I always like to put my vertex in the middle and go up a few points and down a few points. So if I make this -1, -1 times -1 is +1. So that's going to go at -1, +1. If I plug in +1 and square it, it is also going to give me +1. If I plug in 2 and square it, that's going to give me 4. So now I have a few points on my graph that I can see the shape. The good thing about the axis of symmetry is it really cuts down on your work. If you have the axis of symmetry, you know that if this point is 1 space away from the axis of symmetry, then the one across from it has to be 1 space away. So I know that if this is 2 spaces away from the axis of symmetry, then its other point is going to be 2 spaces away from the axis of symmetry. Okay, so there is our parabola, the name of the shape. And I'm going to draw arrows on that because if I plugged in more values, I would be able to make the lines continue. Okay, so what's our y-intercepts? It's, again, the origin. So 0, 0. Our zeros are where we touch the x-axis, which in this case is the same. So your examples will not be quite this obvious. It's just because this is the parent function, so it's the most basic function you can have. Our domain is going to be negative infinity is less than x is less than positive infinity, or all real numbers. And then our range, can our graph go below the vertex? No, it cannot. So it's any value above the vertex. So we're going to say y is greater than or equal to 0. And one thing I left off at the vertex, the min-max, you always have to decide if it's the minimum value or the maximum value. So if your graph cannot go any lower than this value, then you have the minimum value. I apologize, I left that off. All right, our next example. Oh no, this is on one of your assignments. X squared minus 4x, okay? So just like last time, I'm going to start by finding my axis of symmetry. So my A in this case is 1, my B in this case is negative 4, and my C in this case is 0. Okay, so to find my axis of symmetry, I'm going to start with that formula. Opposite of B over 2 times A. In this case, it would be the opposite of negative 4 over 2 times 1. So the opposite of negative 4 is positive 4. Divided by 2 is 2. So our axis of symmetry is going to be at x equals 2. Because remember, it's always written as x equal because it's a vertical line. So I'm going to do my best to draw a vertical line where x equals 2. Whoa. Well, you know, it's all good. It's semi there. All right. Not my best work, but it'll do. All right, so now we're going to go from there to find our vertex. We know this 2 has to be the x value of our vertex. And we know that because it has to be on the axis of symmetry. So if 2 is the x value of my vertex, I can plug that in to the equation. 2 squared minus 4 times 2. And that'll give me my y value of my vertex. So 2 squared is 4. 4 minus 4 times 2 is 8. PEMDAS still counts, or GEMDAS, whatever you want to call it. And that gives me negative 4. Okay, so my vertex is at 2, negative 4. Okay, and I'm going to work from there to determine the other points. Okay, so I'm going to start a table, and I write really big, so I take up all the space. And I'm going to put my vertex point in the middle of it. And I'm going to work around that point to find other values. So if I plug in 1, 1 squared is 1, minus 4 times 1. So 1 minus 4 is what? Negative 3. If I plug in 3, 3 squared is 9. 9 minus 4 times 3. 4 times 3 is 12. So 9 minus 12 is also negative 3. So now I can add those points to my graph. At 1, we're going to be at negative 3. At 3, we're going to be at negative 3. And then I'm going to do one more value, an easy one, 0. 0 squared is still 0, minus 4 times 0 is still 0. I apologize for my children. We've been cooped up too long. Okay, so knowing that this is my axis of symmetry, I know that if this is 2 spaces from here, then its opposite point needs to be 2 spaces from there. So I have found my other points based on that. So if you wanted to know why the other teacher is recording the videos, it's because of all this ruckus in my background. So I apologize for that. All right, so we now know our y-intercept based on this graph. It's this point right here, which is the origin. So we're gonna put down the y-intercept. We know our zeros, and we actually have 2 of them. It's the y-intercept in this case, and then also 4. You can either write it as x equals curly brace. My curly braces always turn out terrible on here. 0, 4. Or you can just write 0 and 4, which I probably should have done since it's so ugly. Our domain is still all real numbers, or negative infinity is less than x is less than positive infinity. And our range, right here, can our points go lower than this vertex? No, they cannot. So our range is going to be anything above this line. But our graph is touching -4, so it has to be equal to. So it's y is greater than or equal to -4. And you'll notice that your vertex point gives you a lot of these values. It gave us our starting place, or I'm sorry, your axis of symmetry, it gave us our starting place for the vertex, and then our vertex actually gave us our range number. So they're all very intertwined. And this was also a minimum because of the shape of the graph. All right, so this is an example from the Google Slides homework. And it's one where they just gave you the graph and the zeros. I thought it might be helpful for you guys to see how to work backwards from here, okay? So the zeros were given to us. We know that it crosses the graph at -9 and -3. From the graph, we can actually find our symmetry because we know our vertex. Oh, my lines get worse and worse. Well, I shouldn't try to use the mouse, that's why. Okay, I can label my axis of symmetry as x equals -6, because that's where the line crosses. We know that our vertex is a minimum value because of the way our graph is facing. It's the lowest point on the graph. We can count to find that vertex point, which we know that x value is -6 because it has to match our axis of symmetry. We know that it is at -6, -9. Okay. We can't see our y-intercept, so we're going to come back to that. This should have arrows on it. Most of the ones do on your homework. Some of them got left off when the graph cut off like this, but this would be a domain of all real numbers, and a range of y is greater than or equal to the -9, because that's the lowest y value, and it's going to continue all the way up. So now we have to figure out how to write our equation. I'm sorry, I just had a brain fart. So when we're writing our equation, we are going to, this is so much easier in the classroom. So vertex form of a quadratic. We gave you the vertex form in all of the Google work because it's not a standard that you're going to be tested over. So you'll notice on all of your slides that we plugged the vertex form in for you. But we already have the vertex form if we have the vertex. So in this case, the -6, -9 is the vertex, and that is going to lead us to our vertex form. Vertex form is y equals a parentheses x minus h squared plus k. So the vertex